Welcome to this explainer, everybody. This is your ultimate ICSE MasterClass blueprint for scoring a perfect centum in chemistry. I'm so incredibly pumped to guide you through one of the most foundational and honestly, one of the most fascinating chapters in your entire syllabus, acids, bases, and salts. If you're looking to absolutely dominate your board exams, well, you're in exactly the right place. We're going to completely deconstruct this chapter, clear up all those notoriously confusing concepts, and give you the exact strategies you need to secure that top-tier score. So grab your notebooks, get focused, and let's conquer this thing together. All right, so here's our highly structured roadmap to a centum. We're covering the core of acids and bases, high-yield chemical reactions, diagnostics and indicators, cracking salt classifications, mastering salt preparation, and wrapping up with our ICSE MasterClass strategy. Let's get right into it. Section 1, the core of acids and bases. Let's build your foundation with the exact scientific keywords examiners are actively hunting for. Because in the board exams, close enough just isn't good enough, right? You absolutely need the precise terminology. So, what exactly makes an acid an acid? Now, you might already know that acids are sour, like the citric acid in lemons or the acetic acid in the vinegar you put on your food. But what's the exact chemical definition that's going to guarantee you full marks on your paper? It's not just about taste, guys. It is all about molecular behavior. Here's the absolutely crucial point. An acid must be in an aqueous solution to react with water and form hydronium. An acid yields hydronium as the only positive ion. And conversely, a base dissolves to yield hydroxyl ions, that's OH-, as the only negative ion. Listen, if you don't write the word only for these ions, you are going to lose marks. Remember, hydrogen ions, they can't exist independently. They immediately combine with water molecules. Okay, I want you to lock this exact chemical equation for the ionization of sulfuric acid right into your memory. Notice how the acid interacts with water here. It forms the hydronium ion, H3O+, alongside the corresponding negative ions. Whether we're talking about hydrochloric, sulfuric, or nitric acid, dissociation always leads to these hydronium ions. That right there is the true modern chemical signature of an acid. Now, listen closely to this part, because students constantly mix these two concepts up. Strength versus physical concentration. A strong acid completely dissociates into ions, while a weak acid only partially dissociates. Concentrated, on the other hand, just means there's a high percentage of acid mixed into a tiny amount of water. You should also remember classification by basicity, like how sulfuric acid is dibasic because it yields 2 hydronium ions per molecule. Make absolutely sure you can distinguish between these beautifully. Moving on to Section 2, high-yield chemical reactions. Next up, we're breaking down the critical chemical properties where all those tricky observation-based questions originate. The board absolutely loves asking, what do you observe when? And this is exactly where we secure those marks. Take a mental screenshot of this table right now. It is your ultimate cheat sheet for instantly identifying gases and observations in practical chemistry questions. When dilute acid hits a carbonate or bicarbonate, it liberates carbon dioxide, and your observation is brisk effervescence. If the acid reacts with a sulfite, it releases sulfur dioxide, which you identify by its harsh, choking smell. And if it reacts with a metallic sulfide, it produces hydrogen sulfide gas, instantly recognizable by its distinct, terrible, rotten egg smell. Mastering this table means you can instantly crack literally any identify the gas or state your observation question. And here is a classic trap. Examiners love to catch you out with nitric acid. Generally, when active metals react with acids, they liberate hydrogen gas. But nitric acid is a powerfully strong oxidizing agent, so instead of letting hydrogen gas escape, it immediately oxidizes it to form water. However, and this is a favorite board exception, so pay attention, if you use precisely 1% dilute nitric acid and react it with either magnesium or magnesium, it will liberate hydrogen gas. Do not let them trick you with this exception on exam day. All right, Section 3, diagnostics and indicators. Let's tackle indicators and those notoriously confusing give reason questions. These are the ones that separate the average scores from the 100%ers. Use this classic, super effortless mnemonic trick. Bases are bitter to taste, and they turn red litmus paper beautifully blue. B for base, B for bitter, B for blue. It's so incredibly simple, but it's gonna save you when you're under exam pressure. And conversely, acids are sour and they turn blue litmus paper red.
Also, don't forget about phenolphthalein. It stays totally clear and colorless in acids, but magically turns a vibrant pink in an alkaline or basic solution. Methyl orange is another great one to remember. It turns pinkish red in acids and yellow in bases. Lock these indicator colors in, guys, because they are basically guaranteed 1-mark MCQ questions. Now, check out this classic board trap that shows up year after year. Give reason why dry HCl gas won't change dry blue litmus paper red. Do you know the answer? Without moisture, HCl cannot ionize. It doesn't produce any of those crucial hydronium ions we talked about earlier. And no hydronium ions means no acidic properties are displayed whatsoever. It absolutely requires an aqueous solution to show its true colors.
Section 4. Cracking salt classifications. Okay, let's dive into this next section, which just so happens to be where most students lose marks: understanding and classifying salts. We really need to distinguish between normal, acid, and basic salts.
Here's the deal. If an acid gives up every single ionizable hydrogen atom when reacting with a base, it forms a normal salt. Think sodium chloride or sodium sulfate. But if it only gives up some of its hydrogen atoms, it creates an acid salt, like sodium hydrogen sulfate. This partial replacement means the salt still retains an acidic character. Understanding this difference is absolutely vital when they ask you to identify the type of salt based on a chemical equation.
Moving to Section 5, Mastering Salt Preparation. Now, how do we actually prepare these specific salts in the lab? This is perhaps the most rigorous part of the syllabus, but I promise we're going to make it incredibly straightforward. So these are your 4 primary preparation methods. If you're making an insoluble salt, you use precipitation. If you need a soluble salt from an acid and an alkali, you use neutralization. And for simple displacement, you must use active metals that are above hydrogen. Remember the mnemonic, please stop calling me a careless zebra, for potassium, sodium, calcium, magnesium, aluminum, carbon, and zinc. You've got to rigorously understand exactly when to deploy each method based on the salt's solubility. I need you to memorize these exact previous year question pairings, matching the specific salt to its perfect preparation method. To make iron 3 chloride, use direct combination by reacting heated iron directly with chlorine gas. To make zinc chloride, use simple displacement. For insoluble lead sulfate, force it out via precipitation. And for potassium nitrate, use neutralization. Lock these exact pairs in your brain. Finally, Section 6, ICSE MasterClass Strategy. Okay, superstars, let's finalize your winning strategy with some high-level board tips and an exclusive resource that's going to act as your unfair advantage.
Always remember the concept of amphoteric substances. Aluminum hydroxide is amphoteric, meaning it uniquely reacts with both acids and alkalis to form salt and water. Examiners will frequently ask you to identify the substance that can react with both a strong acid and a strong base. The second you see that, your mind should immediately jump to aluminum or zinc hydroxides and oxides. To secure that premium top-tier score, make sure you hit subscribe on ICSE MasterClass right now. We are entirely dedicated to making sure you score that 100%. And absolutely make sure you join our Telegram channel to download your ultimate free handwritten notes, comprehensive formula sheets, and the most rigorously vetted previous year questions for this exact chapter. All the resources you could ever need are waiting for you right there.
So, you've got the blueprint for a centum, but can you apply it to flawlessly identify an unknown salt in your next practical? You are now fully equipped with the absolute blueprint for a centum in acids, bases, and salts. You understand the core modern concepts, the indicator mnemonics, the chemical reaction traps, and the rigorous salt preparation methods. But are you truly ready to dominate the exam room? When they hand you an unknown salt and ask you to observe its reaction with an acid, are you going to remember the choking smell of sulfur dioxide or the brisk effervescence of carbon dioxide? Review your notes, test yourself, and keep striving for perfection. Until next time, keep learning, keep dominating, and I will see you in the next explainer.